Okay. So again, sorry for short notice. So we will start early today because I have another event after 11. Okay, so again, so for today's class, we will continue on continuous random variable, maybe uh, for 1 hour, and then maybe we will discuss a little bit on the question that I already shared with you in the Telegram for previous test one. Okay, we will start with continuous random variable. So actually in your chapter 3, random variable, so we will have discrete and also continuous random variable. Okay. So when we mention about discrete random variable, so normally it is called the probability function, we call as probability mass function. Or we can also state that this one is your PMF. Okay. The abbreviation for discrete probability function is just PMF, which is probability mass function. But when we have a continuous probability distribution, so this one is related on continuous random variable. Okay, for example, let's say if you have continuous random variable, it may be your weight, your height, okay, and then time. Okay, that one will involve interval and also in terms of decimal point. Okay, so if we have a discrete random variable, it's the whole number. So it can be either 0, 1, 2, and 3, and so on. So that one is a discrete. So this one is continuous random variable that involve, the value involve decimal point or in terms of your interval. Okay, so let's say we define your x a random variable on a sample space S, again, space S, list all possible outcome. Okay, suppose that we have the set A less than equals to X, less than or equals to B. Okay, and we want to find the probability. Okay, so a random variable X is a continuous random variable. Okay, if there exists a function, which is your Fx, also your probability, which is greater or equals to 0. And then we have to integrate, okay, such that you have x between a up to b. You can integrate from a up to b your fx dx. Okay, fx here, okay, so we call as pdf, which is your probability density function. Okay, probability density function. So this one is fungsi ketempatan kebarangkalian. So we will integrate over the range from A up to B, fx dx. Okay, itu integration biasalah ya, fx dx. Okay, so for any value, let's say if you have y, so you will integrate from A up to B, fy dy. Okay, and then the concept for continuous random variable, you have the properties again. The same thing, fx must be greater or equal to 0. And then when we integrate over the range, it should give you equals to 1. Okay, let's say let's say our range here is from minus infinity up to infinity. Your fx dx, if you integrate over the range, okay, depends on the function. Okay, what is the range given? If you integrate that one, it should give you equals to 1. Okay, so itu concept in continuous random variable. We play around with integration. Okay, so when your x is continuous, okay, so it's the same thing if you have, let's say, x is, does not include a less than x, less than equals to b. It's the same thing if you write x between a and b, and also probability x equals to b. It's the same thing if we have probability x between a and b. Okay, why? Because if you have x from a up to b, you still integrate a to b. When you have this one, you still integrate a to b fx dx. Okay, because if this one is a continuous random variable, okay, continuous random variable, that means it cannot take exact value. Exact value, what is mean by exact value? When you have, let's say, probability x equals to 2. Okay, this one will give you 0. because continuous random variable cannot take exact value. It's different from your discrete. If you have a discrete, yes, you can solve probability x equals to 2. But for continuous random variable, it must be in terms of your interval. Okay, so that's why it state here, if we have this one, it does not matter whether an endpoint of the interval is included or not. Okay, tak kisah ada equality signs or not, you still integrate over the range given your fx dx. But this is not true when your x is a discrete random variable. So kalau let's say this one is a discrete, if you have probability, okay, sekejap ya. Okay, if you have a discrete random variable, probability x less than, saya punya pen tak boleh tulis pula. Okay, if you have discrete random variable, probability x less than 3 and also probability x less than or equals to 3 is different. Okay, so kalau probability x less than 3, so that means it does not include 3. Okay, you just solve up to x less than equals to 2. But if you have x less than or equals to 3, okay, so that means you will have from x, for example, we start from x equals to 1. So probability x equals to 1 plus probability x equals to 2 plus probability x equals to 3. Okay. For example, if our x start from 1. Okay. So that is the main difference if you have a discrete and continuous. Okay. Kalau continuous, okay, for example, probability x less than 3. So maybe you will integrate minus infinity up to 3, your fx dx. And again, if you have probability x less than or equal to 3, so it's the same thing. You will integrate from minus infinity up to 3, your fx dx. Okay, so that is the main difference between discrete and also continuous random variable. Okay, so again, so itu dia punya konsep dia. Okay, kenapa, why you have for continuous, it doesn't matter if you have equality signs or not. You still integrate over the range. Same thing. Yeah, because if we have exact value, probability x equals to a or any constant value, you will get 0 because continuous random variable cannot take exact value. So that's why everything must be in terms of continuous, in terms of interval lah ya. So kalau kita ada, for example, if you remember maybe from binomial, you want to change to normal. Okay, so you need to add plus minus. Okay, dia punya normal approximation lah. Later on, we will see on chapter 5, I think the last chapter. Yeah, so itu dia punya main difference dia. Okay, properties for probability density function. So all probability must be greater or equals to 0. Okay, must be greater or equals to 0. And then total probability must equals to 1. So that means you will integrate here. Okay, from minus infinity up to infinity, your fx dx is equals to 1. Okay, all function in your continuous must be positive lah. Fx must be greater or equal to 0 for all x for any real number. Okay, if you have integration, or if you want to find the probability x between a to b, so you just integrate from a up to b fx dx. Yeah, so itu dia punya konsep dia for continuous random variable. Okay, let's say if we refer to the first exercise here. Okay, So again, you have your x is continuous random variable. Okay, basic. So if you want to find c, the function is given c x squared plus 1 is only defined from 0 up to 1. Otherwise, it will give you the density is 0. For example, let's say if you have between, katakanlah 2 less than x less than 3. So this one, you get 0 density. Because the function is only defined between 0 ataupun from 0 up to 1. So c x squared plus 1. So that means if you want to find your c, okay, concept probability, so everything you will integrate from 0 up to 1. You have c x squared plus 1 dx set can equals to 1. Okay, because this concept here, total probability is equals to 1. Okay, sebab kat sini range dia is just from 0 up to 1. So you integrate and then you solve, you get what is the value for C. For example, let's say this one. So katakan C kita faktorkan. So you have x cube. Okay. Ya, teruskan dulu. Nanti saya nak betulkan saya punya ni. Ya, cuba integrate dulu. Okay. So C x square over, sorry, square. X cube, x cube over 3 plus x 0, 1 and then set can equals 1. Okay. So selesaikan dapat berapa nilai C? So we have C 1 over 3 plus 1 equals to 1. So what is the value for C? Dapat apa? 3 over 4? Is it? Okay, so you check, you get C should be 3 over 4 lah dalam case ni. Okay, so that's mean 1 over 3 plus 3 over 3, so solvekan C should be 3 over 4. Okay, that one. So itu maksud dia. So you have a function C x squared plus 1, but this one is only defined from 0 up to 1. Okay, otherwise, it should be 0 density. Okay, so again, you want to find C, the same concept that you have for discrete random variable. Okay, discrete random variable. So you just have, for discrete pun kita ada hasil tambah. Total probability is equals to 1. Okay, and then if you want to find for continuous random variable, so you have total area. Okay, total area under the curve is equals to 1. So that's mean total you punya fx dx over the range. So range here is 0 and 1. So you just integrate from 0 up to 1, set can equals to 1. And then you solve lah. What is your constant value for this case? Okay. Just off dulu. Okay. Okay, let's say we refer to exercise 2 dulu. Okay, nanti baru kita tengok yang modul punya. So ini just the same thing lah. Ini modul cuma saya add on kan sedikit exercise yang berbeza sikit lah. Okay, exercise 2. So this one, you have a probability density function. Okay, you have two range. Okay, first one, minus 1 less than y less than or equals to 0. The other one, 0 less than y less than or equals to 1. So you want to find the value for C. Okay, so same concept. Total area under the curve ataupun total probability is equals to 1. So when I mention total area under curve tu maksudnya, let's say lah if you have okay, function macam ni kan. Okay, so for example lah, this one is your A, this one is from your B. Okay, okay, so this is your value lah. So that's mean you integrate your function, the area under the curve. Okay. So again, if you have the total area, it should equal, it should give you equals to 1. So kat sini kita ada 2 range. Okay. So you want to find C, so just follow balik. Okay. So that's mean kita punya Fy dy ni, kalau kita integrate, it should give you equals to 1. So that's mean you have from minus 1 up to 0. So we take the function 1 over 5 dy. Okay, plus from 0 up to 1, 1 over 5 plus cy, okay, dy, okay, because you will integrate with respect to y, okay, setkan equals to 1. Okay, cuba selesaikan, what is your C? Once you get your C, then you can solve yang bawah tu. Okay, so dapat So you should get the same answer lah as Lokman. So you have C equals to 6 over 5. Okay, semua boleh dapat, selesaikan. So you just setkan, solvekan your punya integration je lah. So that's mean this one you should get 1 over 5. Alamak, saya punya ni. Sekejap ya. Letak dalam. Okay, 1 over 5. Y. So you just substitute the value from okay, from minus 1 up to 0 and then plus. Okay, 1 over 5 y cy square over 2 and then from 0 up to 1 again equals to 1. So selesaikan you punya value, you should get C equals to 6 over 5. Okay, now you use the value 6 equals to 6, C equals to 6 over 5 to find the probability between 0 and 0.5. Okay, cuba selesaikan. Okay, so you get C equal to 6 over 5. Now you want to integrate from 0 up to 0.5. So kat mana range dia? So yang kita ada from minus 1 up to 0, 0 up to 1. But now you just want to find the probability between 0 and 0.0. So 0 up to 0.5. So that's mean you just integrate 0, 0.5. So this range. So 1 over 5. C tadi 6 over 5 y dy. So selesaikan. That is your probability. Okay. So ini berapa? So we have here is y over 5. 6 over 10 y square. And then substitute lah 0, 0.5. Okay, cuba selesaikan. Bagi jawapan akhir eh. And then one more thing you need to check is the answer for your probability here cannot exceed 1. Okay, ataupun have a negative value. Okay, you have to make sure the answer for your probability must be between 0 and 1. Ya, itu konsep for probability lah ya, either discrete ataupun continuous. Okay, cuma sometimes student make careless mistake. Okay, you didn't check, you already integrate and then you get something else, the value let's say you get negative value ataupun exceed 1, show itu salah ya. Okay, Lokman punya answer 2/5. Okay, hopefully semua orang dapat Saya ambil je jawapan daripada Lokman. Salah. Okay, salah. Apa jawapan dia? Yang the rest, apa jawapan? Sekejap, padam. Okay, so cuba selesaikan and then you should get lah berapa 0.5. Okay, 1/5 plus 6. Saya punya okay. Okay, jawapan dia berapa? Okay, Bazrin dapat 1/4, yang the rest okay, 0.25 Okay, thank you. Okay. So that is the question. Kalau let's say kita ada dua range lah. So check one by one. Okay, sometimes kita ada split range. Katakanlah kamu nak dapatkan probability. For example, you want to find probability, let's say, apa kita buat? Okay, let's see lah. From minus 0.5, okay, less or equals to y. Maybe less or equals to 2, for example. Okay. Bila diberi soalan macam ni, check dulu dia punya range dia. So that's mean you have minus 0.5 up to 2. Okay. So that's mean minus, first you integrate minus 0.5 up to 0. Okay, for 1/5. Plus, and then from 0, you just integrate up to 1. Okay, for this one. Second part dia. Sebab antara 1 hingga 2 ni, dia termasuk sini, which is 0 density. Okay, so just double check. Jangan integrate teruslah minus 0.5 up to 2. So itu pun sometimes the student make careless mistake. So check the range what will given to you. Okay, what is given to you. Okay, boleh Okay. Kita tengok balik soalan dalam task 3.14. Sekejap saya share dulu. Okay, kita tengok dulu dalam modul. Okay. Saya tengah loading ni saya. Okay, I stop sharing this one first. Okay, so the same concept dalam, let's say, if you refer to your module. Okay, so first we start with introduction for continuous random variable. So I already give the example. For example, width and also height. Okay, and then the same thing here. So you want to find, verify whether this one is a probability density function for random variable. So what you need to do is your all probability, your fx must be greater or equal to 0. Okay, kita punya function tu sentiasa positif. Okay, you need to write that one. Second, you need to integrate from 0 up to 1, your density function. Okay, so make sure once you integrate, you will get 1. So then you can state that this one is a probability density function for random variable x. Okay, next, you want to find the probability. Okay, so probability between 0.5 up to 1. So we just integrate from 0.5 up to 1. What is your density function? Okay, so that one. So ini pun sama lah ya, task 3.13. Okay, tapi kita, okay. So the same thing here, maybe you can try on your own this one. So task 3.13. So we have here is between 0 and 1. Y is between 2 and 3. So here cy 1 minus y, and then you have another density is 1 over 2. So you want to find the value of C. Okay, the value of C. So again, you integrate from 0 up to 1 for this function, plus 2 up to 3, then you set equals to 1. Then baru kita selesaikan apa dia punya nilai C. Okay. Once dah dapat nilai C, baru kita compute balik dia punya probability ni. Okay, so ini pun check lah. You want Y from 0.5 up to 2.5. So the range is 0 up to 1. So again, integrate 0.5 up to 1, and then 2 up to 2.5. Okay, antara 1 dengan 2 tu 0 density, which is belong to here lah. Kamu punya 0 ni, which is 0 otherwise. Okay, last, baru you compute your probability. Y greater than or equals to 2. Okay, Y greater than or equals to 2. So check balik range dia ada apa. So that's mean from 2 up to 3 je lah yang you integrate, which is your density is half. Okay. So itu untuk continuous function Nanti later on you can try on task 3.13. Okay, kita go back kita punya slide tadi. Sama juga saya ambil juga sikit daripada modul. Okay, task 3.14 So here you have total number of hours measured in units of 100 hours. Okay. A family runs a vacuum cleaner over a period of 1 year is a continuous random variable, and we have this density function. Okay. You have total number of hours measured in unit of 100 hours. So maksudnya X kamu sekarang ni between 0 up to 100 lah sebenarnya. 1 ni 100 up to 200. But since we want to integrate and we want it in terms of simplified form, so kita buatlah antara 0 and 1, tapi sebenarnya unitnya dalam bentuk 100 hours. Okay. So now you have a two range between 0 and 1, and then the other one from 1 up to 2. So you want to find the probability that over a period of 1 year, a family runs their vacuum cleaner is less than 120 hours. Okay, less than 120 hours. So what you want to find is your probability X. Okay, less than 120 hours, kita divide lah dengan 100. Sebab ini unit dia dalam bentuk 100. So that's mean what you want to solve is X less than 1.2. Okay, boleh faham Okay, ini pun sama. Kita akan tukar dia punya unit dia. Sebab ini dalam bentuk 100 hours. So what you need to solve is probability X less than 1.2. So from which range that you want to integrate? So X less than 1.2. So that's mean you will have 0 up to 1. So ini kita ada X dx. Okay, and then plus, okay, 1.2 dia berada pada sini pula. Okay, from 1 up to 1.2, you have 2 minus X dx. Okay, and then cuba integrate what is the probability. Okay, so everyone got the answer 0.68 Okay, less than 1.2. So again, you integrate from 0 up to 1. Okay, and then from 1 up to 1.2, so the density is 2 minus x dx. So integrate with respect to x, so this should give you the value is 0.68. Okay, so sama juga yang ni, between 50 and 100. Okay, so what you need to solve is 50 divided by 100, so 0.5 less than x less than 1. So it just belong to the first range lah, yeah. So again, from 0.5 up to 1, your x dx. Okay, and then x squared over 2. So just integrate lah, yeah. Okay, kita gunakan basic integration, just basic je lah, ya, for kita punya statistik ni. Okay, and then you solve lah. What is the value for your probability? Okay, boleh ya? Okay, so you get 0.375 ya. So itu konsep dalam kita punya continuous random variable. So check on your range, which range give you the value lah ya. Ni. Okay. Ada apa-apa soalan ke setakat ni? Yeah. So that one. Okay, so gila last answer 0.305. Okay. Tak lagi. Check dulu. Okay, so next we have the concept for cumulative distribution function. Okay, so the same concept that we have for discrete, cuma in discrete random variable, you will have your concept here. For discrete, kita ada hasil tambah ya, kita add on dia punya probability dia. Okay, but again, for continuous random variable, so dia punya konsep adalah integration. Okay, so it's quite different sikit. So there is step by step lah how you want to solve for cumulative distribution function. So here kita ada fx, okay, simbol yang sama. So you will have your capital Fx, probability x less than or equals to x. Okay, fx, probability x less than or equals to x, which means that you will integrate from minus infinity up to x ft dt. Okay, so kita ada here maksud capital Fx sama, which is probability x less than or equals to x. For example, let's say if you have f2, so it gives you probability this one. Okay, but for continuous random variable, we will integrate it. Okay, x less than equals to x. That means kita start lah from minus infinity ke apa ke? Okay, so we start from minus infinity. Itu basic kita punya range lah, from minus infinity up to infinite. Okay, so from minus infinity up to x ft dt. Kenapa saya tulis ft dt? Sebab nanti bila kita integrate ft dt, kita dapat capital F. So kita nak masukkan balik nilai x. So normally ini cara yang betul menulis. Dia kalau macam ni, okay, katakan ini fx dx, in terms of writing for mathematical equation, salah. Okay, walaupun akhirnya jawapan dia sama. Tapi in terms of writing your mathematics punya equation tu, tak bolehlah kita nak integrate fx dx. Tapi lepas tu kita nak masukkan dia punya value x juga. Okay, so it should be different notation that we use. Okay, for example, nak guna fw dw pun boleh, fu du pun boleh. So this one kita just guna je lah ft dt, and then you will integrate from minus infinity up to x. Okay, so that one for your understanding. Okay, value akhir tu sama tak? Okay, tapi cara menulis je. Okay, cara menulis notation tu yang penting dalam mathematics. Okay, then you have X ni from A up to B ataupun between A up to B, you will have FB minus FA because you integrate A to B fx dx. When you integrate your small f, you will get your capital Fx. And then you masukkan kan AB. So you get capital FB minus FA. Okay, FB minus FA. Okay. So again, one more thing. When we have a capital Fx, ini kita dah dapat capital Fx kita integrate Fx, kita ataupun saya tulis balik, kita integrate small Fx macam tu. Okay, kita dapat balik capital Fx plus C lah kalau let's say kami run apa. You have indefinite integral and then you have definite integral. All the things you already learn in your mathematics, right? Yeah. So ini kita tak adalah, saya tak adalah nak ajar balik integration lah, how to integrate. We assume you already know when you join our statistics class. Okay. So integrate your small fx, you will have capital Fx. Okay. So integration dengan differentiation. Okay, so kalau kita differentiate balik capital Fx, kita akan dapat balik small fx. Okay, ini dia punya relationship that you have to know for continuous. Okay, this is your capital Fx, kamu punya cumulative distribution function, CDF. This is your small fx, which is your density function, your PDF. Okay, differentiate your cumulative, it will give you back your probability density function. Okay, sebab kita integrate small f tu, kita dapat capital F. Differentiate balik capital F, you will get back your density function. Okay, itu relationship dia. Boleh Okay, let's say we have this probability density function. You want to find your capital Fx. And then you want to solve your probability. Okay, tengok satu contoh. Okay, let's go for the next slide. So, tadi kita ada fx 3/8 x square. This one. 0 and 2. Okay, saya tulis balik ke sini. So, fx kita ada 3/8 x square and this one is fine. Selain pada 2, 0 Okay. So, when you want to build up your capital Fx, you need to consider several steps. Okay, so your range here now is 0 and 2. Okay, ni kita punya range. Okay, kita punya range So, kita perlu considerkan several steps. So, first, you need to consider what happen when x less or equals to 0. What happened? Okay, sebab kita punya small fx, kita ada between 0 and 2, 3/8. Otherwise, the function will be 0. Maksudnya, outside this range, your density is 0. Okay, when x less or equals to 0, okay, kita nak dapatkan dia punya capital fx ni. So, what you do is, you will integrate from minus infinity. Okay, kita letak x 0 density. Okay, sebab kita menjawab ini. Yang ni. Okay, otherwise, what happen? Selain pada range ni, apa dia punya nilai ni? So, kita perlu dapatkan juga untuk cumulative. Okay, untuk CDF ni. So, 0 and 2, 3/8. Otherwise, the value is 0. So, you need to integrate from x less equals to 0, your capital Fx. So, you will integrate from minus infinity. I put 2 up to some value of x, 0 density. So, the answer is 0. Okay. And then what happened between 0 and 2? You need a function. Yeah. Sebab dia kumulatif So, that's mean minus infinity up to 0, we put the value. But now, 0 up to some value of x, kita letak density dia Ini 3 over 8. Tapi we substitute, letak sebagai T. Another variable. Okay, kita selesaikan. Oh, sorry. Ini 0 di T juga. Okay, ini 0 plus 3 over 8. Okay, ini kita selesaikan apa? T cube over 3. Gantikan 0x. So, it will give you x cube over 8. Ya, dapat 3 to cancel out. So, x cube over 8. So, that is a function. Okay, now kita consider pula what happen when your x greater or equals to 2. Kat sini, satu lagi kamu nak letak equality ke, tak nak letak equality ke, tak kisah sebab this one is continuous. Kalau tak nak without equality signs pun, it's okay. Okay, because it does not affected lah Sebab this one is a continuous random variable. Okay, sebab exactly value x equals to tak ada 0. Dia punya answer. Okay, x greater or equals to 2. So now you want to find your capital fx. Okay, kita start balik. Okay, minus infinity up to 0. 0 dt. Okay, plus 0 up to 2. 3 over 8 t square dt plus 2 up to x 0 dt. Okay. So, bila kamu selesaikan this one, so this one will give you, of course, 0. Ini pun sama juga 0. Bila kita integrate 3 over 8 t square dt ni, it will give you the value should equals to 1. Okay, the answer here, selesaikan dulu, tunjukkan je sikit jalan kerja dia. You integrate that one, so you get 1. That is your capital fx. Okay, sekarang ni, sekejap ya. Okay, so we have here, okay, saya letak balik, susun balik. Okay, so now I will have fx. Okay, I put in terms of function. Okay, 0. Okay, apa tadi? Kita ada x less equals to 0. And then kita ada apa here? X cube. And 1. Okay, itu kamu punya cumulative. Gitu. Okay. Okay, so this is your cumulative distribution. Okay, you will have 0 for x less than equal to 0. Between ataupun from 0 up to 2, you have x cubed over 8. So x greater or equal to 2, you get 1. Okay, this is your cumulative distribution function. Maksudnya kita menjawab. Kita ada x less than 0, 0. X greater than 2. For example, x equals to 3, x equals to 4. The answer for your cumulative is equals to 1. But between 0 and 2 ataupun from 0 up to 2, the answer is x cubed over 8. Okay. Tadi kita dah mention dia punya relationship between cumulative and your density function. So this is your tadi CDF lah. Okay, katakan saya minta kamu dapatkan small fx. Kita nak double check. Kita dapat tak balik small fx kita? Okay. Okay, so you get this one. Okay, kalau kita dapatkan small fx, the relationship is you will differentiate back your capital F. So differentiate 0, you get 0. Okay, for example, this one lah. Okay, differentiate x cubed over 8, you will get 3x squared over 8, right? Okay, between 0, 2. So differentiate 1, get 0. So in here, you can also write back, so 3 over 8 x squared, ini. Okay, otherwise ataupun s square pun samalah ya. It will give you 0. Okay, itu dia punya relationship. So sekarang kita tengok balik kita punya small fx tadi. Kita dapat balik kan 3 over 8 x square. Your density function. Sebab relationship dia, kalau kita ada cumulative, capital F, you differentiate back your cumulative, it will give you back your density function. Okay, differentiate capital F, you get small f. Itu dia punya relationship. Okay, cuma nak build up you punya cumulative distribution function is quite different from discrete. Discrete senang dia, tambah. Okay, kalau dah ada capital F, kamu tolak balik, dapat balik probability function dia. Okay, this one, step by step. So, consider what happen when x less than 0. Okay, between 0 and 2, kita ada reason why you didn't integrate from 0 up to 2 here. Nampak tak kat sini? Saya integrate up to x je. Because I need a function dalam bentuk x. Sebab kita nak differentiate balik, nanti dapat tak kita punya small f tadi. So that's why I just integrate from minus infinity up to 0, 0 up to x. Okay, then you substitute, you selesaikan, you get x cubed over 8. Okay, x greater than 2. So ambil balik, minus infinity 0. Ini baru kita masukkan 0 up to 2, 2 up to x. Otherwise, 0 density function. So you integrate the last value, it should give you equals to 1. Same as your discrete juga. Last value dia mesti capital F dia sama dengan 1. Okay. So the same thing here. You integrate the last one, it should give you equals to 1. Okay. Because total area ataupun total probability dia is equals to 1. Itu dia punya konsep dia. So that's mean, kat sini kita ada 3 step lah. Okay. One range, 3 step. Okay. And then you put back, kalau boleh, letakkan baliklah dalam bentuk fungsi. Bentuk macam ni. Okay, this one. Again, if you want to double check, you differentiate balik. Kalau differentiate capital F, dapat tak balik semua F? Kalau sama, maksudnya betul lah kamu punya capital F tu. Dia punya approach dia. Okay? Boleh ya? Okay, ada apa-apa soalan? Do you have any question up to here? Okay, boleh follow ke? Ya. Yeah. Okay. Okay, dalam modul pun sama lah kamu boleh baca balik dia punya example tu, I think. Okay, kita tengok sikit lagi. Okay, kita tengok ini task 3.15. Simple je. Okay. So here we give you a continuous random variable, tapi kita dah bagi set-set dalam bentuk capital F. Okay, capital F dia, so x less than 2, 0. So from 2 up to 5, you get x minus 2 square over 9. X greater or equals to 5, you get 1. So ni kita nak dapatkan density function je. So as I mentioned, the relationship tadi. Okay. So maksudnya kalau nak dapatkan density, kita akan differentiate your capital F. So that's mean you will differentiate your capital Fx. Ini je lah. Kita ada 2 x minus 2 over 9. Okay, so tulis balik. Okay, tulis balik dalam bentuk fungsi. Okay, so that's mean 2 x minus 2, 9. Okay, ini from 2 and 5. Okay, selain pada 2, 0 lah. Okay, because you differentiate 0, 0, differentiate 1 pun 0. So otherwise, you get 0. Okay, sekejap ya, saya pilih lagi. Okay, so that one. Ya. Tu mungkin dalam 2 markah je lah ya. Kamu differentiate kan and then write down lah in terms of function. Okay, sebab kita nak dapatkan density function dia. So differentiate kan, you get 2x minus 2 over 9 and then differentiate 0, differentiate 1. Okay, and then rewrite back. Yeah, so itu relationship capital F, small f. So check what is given from the question. So cumulative distribution function. So capital F. So kalau small f, dia bagilah small f tadi. Yang tadi. Sini. Probability density function. So read the question carefully. Okay. Okay, kita try the last one So task 3.16 and then kita stop lah kat situ dulu. Okay, task 3.16. Okay, cuma berazanya di sini kita ada 2 range. Okay, 0, 1, 1 to 5. Okay, kamu nak dapatkan kumulatif ni, capital F. So, step by step lah. Okay. Okay, first, kita consider dulu kita punya step So, kita buat one by one dulu. Okay. You consider what happen when x less or equals to 0. Okay, sama juga. Follow balik. Capital Fx. Jadi, from minus infinity up to x. Okay, ini patutnya dia ada satu lagi lah kot 0 otherwise. Tambah satu lagi lah 0 otherwise. So you will have here 0 density, so 0. Okay. And then 0. Okay, kita follow je yang tu. Fx. So again, minus infinity up to 0. 0 density. Plus, okay. You will have 0 up to x. Okay, here. So kita ada t square dt So again, this one is 0. Okay. Plus t cube over 3. 0 up to x. X cube over 3. So that one. Okay, itu for 0 up to 1 So kalau nak double check, differentiatekan x cube over 3. So you will get 3x square over 3. So cancel out 3, you get back your x square. Okay. So now kita consider pula antara 1 hingga 5 ni. Okay. So again, 1 less than 5. Okay. So your capital Fx. So kita ambil balik minus infinity up to 0. 0 dt plus 0 up to 1. Apa tadi? X square. So kita ada t square dt plus. Cuba integrate ni dipanjang sikit lah. Kita ada 1 up to x 5 minus t. Nampak satu ni? 5 minus t over 12 dt. Okay, cuba integrate kan. Okay, dapat ya? So this one kita ada capital FX tu. So it will give you berapa tu? Dia punya answer dia should be okay, 5. Ni saya sambung sini ya. Okay, so once you integrate, okay, so itu 0, 0 lah ya. So ini T cube over 3 and then you just masukkan nilai 0, 1 and then kita ada 5T over 12 minus T square over 24 and then ganti nilai dia 1 up to X. Okay, simplifykan semua tu and then double check your answer should give you 5 over 12 X minus X square over 24 minus 1 over 24. Kalau nak simplify lagi, boleh jugalah simplify kan. Okay. So again, you can double check here. So kalau kita differentiate this one, okay, differentiate 5 over 12x, you get 5 over 12. Differentiate x square over 24, so you get x over 12. So kita dapat balik your small f. Okay, differentiate this one, 0 lah. Okay. And then the last one, kita dapatkan pula untuk apa? X greater than 5. Okay, so cumulative. So ambil balik kita punya nilai. So minus infinity 0, 0, 0 dt. Okay. Okay, 0 dt plus okay, 0 up to 1 t square dt and then 1 up to 5 minus t over 12 dt plus 5 up to x 0. So ini 0, this one 0. So solvekan this one. Okay, double check tunjukkan dia punya jalan kerja lah ya. Okay, so 1 over 3 t cube over 3. So the same thing, 5t over 12 minus t square. Okay, 1 to 5. Okay, so selesaikan this one. Tunjukkan dia punya jalan kerja dia and then you just will get this one equals to 1 lah ya. Once you substitute. Okay, jangan simply letak equals to 1 ya. Tunjuk a little bit on your step how you get this one is equals to 1. So this is your cumulative distribution function eh. So first step ni, capital Fx ni. So just last kali kamu tulis balik dulu kamu punya ni dalam bentuk fungsi. Okay. Your capital Fx. Okay. So that's in. Okay. So that's mean x0, 0 lah ya. So 0, 1 kita dapat x cube over 3. Okay, and then 1 and 5. Okay, 1 and 5 table. So you have here 5 over 12x. Okay, and then the last one, you get 1. Okay, for x greater than 5. Okay. So, ini greater or equals pun okay jugalah ya. Gantikan dia punya nilai itu sama. Okay, so this is your function for your cumulative distribution function. Okay. So that's mean kalau kita ada this one, okay, you already have your small fx, and then you derive. So this one you include 2 range. So step by step. So consider what happen when x less than 0, between 0 and 1, but we just integrate from 0 up to x. And then the next one, 1 up to 5. So that's mean kita dah ada minus infinity up to 0, 0 up to 1, and then 1 up to x. Okay, satu lagi, and then baru kita integrate the last one. What happen when you consider x greater or equals to 5. Okay, so that's mean otherwise tadi lah ya. So that's mean the punya value capital F dia should equals to 1. So this one is your cumulative distribution function that is your capital F. Okay, ada apa-apa nak di ni? Ada apa-apa persoalan? Ini kalau 2 range So yang tadi saya tunjuk tu adalah 1 range. Okay, 1 range simple je lah So you only have 3 steps. Okay, you have your capital Fx. What happen when x less than 0, between 0 and 2, and then the last one, x greater than 2. So this one. Okay, nak double check, differentiate balik your capital F, you will get your small f. Okay, and then this one, you have 2 range. So at least you have apa ni, x less than 0, 0 and 1, 1 to 5, and then x greater than 5. Okay, once dah ni, present it in terms of a function. Okay, so presentkan dalam bentuk function. Okay, and then kalau nak double check, cuba differentiate balik sama tak dengan kita punya density function. Okay, that is the way how we get this one lah Okay, boleh? Ada apa-apa nak tanya ke? Okay. Okay, so yang ni saya stop sini dulu for your continuous random variable. So later on hari apa? Hari Khamis tu nanti saya continue on this one lah. Kita ada expected value kot yang last part for continuous random variable. And then maybe we'll do some a little bit on your exercise, you punya chapter lah dalam module tu, tutorial tu. Okay, for that one. Okay, ni saya nak go back dulu. Okay, tak ada apa-apa tak ada persoalan Okay, I just stop sharing this one first. Okay, boleh nampak this question that I share in the Telegram. Okay, everyone. Okay, so the same thing here. Again, just for reminder, your test one, again, sama je, 15%. Okay, so duration is 75 minutes, so 1 hour and 15 minutes. So we start at 8 up to 9:15. Okay, and then 15 minutes too for you to scan and upload balik lah dalam kita punya blackboard tu. Okay. So in case if you have internet problem ke apa ke, please mention lah pada saya. Okay, please personal lah personal message kepada saya. Okay, for that one. Mungkin kita akan cari alternatif lain lah untuk kamu hantar dia punya solution. Okay. Okay, so this is the question for sesi I think 2018 kot. Okay. Now to 2022 kan? Kamu punya 2022, 2023 kan? Kamu punya ni batch apa? Bukan batch lah, sesi, di sesi. Okay. So again here, the first question, if you look at the first question, okay, dia ada statement dia. Okay, read the following paragraph carefully. Okay. UTM is on the campaign to fight obesity among its students. So 100 students were chosen at random. Okay. So among the information taken from these students were number of family members, race, height, weight, and monthly family income. Okay. So again here, kalau kita nak state dia punya population dan juga sample. Okay. So kalau population, so since we have the object dia kat sini adalah students. So we mentioned about UTM. Okay, is on the campaign to fight obesity among its student. Dia taklah cakap student fakulti mana ke apa ke, tak ada mention lah Okay. So when you want to state your population, so it should be all UTM students. Okay, all UTM students. So that is your population. Okay, your sample 100 students ataupun 100 UTM students lah. So that is your sample. Okay, population. Because bila kita define kita punya population, the whole object that you want to investigate. A sample is a subset of your population. So whole sample. So that's mean all UTM student is your population. A sample, you take 100 students for your sampling. So this 100 UTM student is your sample. Okay. Markah pun tak banyak sebenarnya. One je lah. So for the data gathered, okay, apa dia punya discrete quantitative dia? So kalau discrete quantitative, so something that you can compute. Okay, and so continuous quantitative and also your qualitative. So discrete quantitative. Okay, kita ada sama ada 0, 1, 2, 3 and so on. Okay, that's mean number of family members. Okay, so your number of family members ni. Okay, so number of family members is your discrete quantitative. Your continuous, kita ada height, kita ada weight, and also monthly family income. Because this one involve decimal point. Okay, kalau qualitative, race je lah, bangsa kat sini. Okay, Malay ke English, Malay ke Indian ke ataupun Chinese. So that is your qualitative. Got it one, Okay, question number 2. Boleh faham definisi population sample? This I just go through I expect everyone already try to solve it. Okay. So again, ini just a rough idea je. So UTM has decided to use body mass index to investigate fitness of its 2018 foundation students. So low BMI shows underweight and large BMI shows overweight. So 100 students were chosen randomly. So kita pilih 100 student. So itu adalah sampling. Okay, we choose randomly 100 students. Okay, so data kamu ni adalah data sample. So this is your tabulated. Okay, your punya frequency table lah So the interval, number of students is your frequency. So compute the mean and standard deviation. So in order for you to compute your mean, what did you need is your your class midpoint, your XI. So find dulu apa dia punya XI. Tunjuklah dalam jalan kerja kamu what is your buat table, salin balik table ni. Okay, buatlah kelas, kata nak buat kelas boundary, buatlah kelas boundary. And then class midpoint, your frequency, your cumulative frequency, everything that you need to solve question number 2. Okay, so show what is your SI. Okay, and then find lah your punya frequency. Tunjukkanlah FI, XI, total balik FI, SI, dapatkan divide by total frequency. Standard deviation, so what is the formula? So you already know this one is your sample standard deviation. So the difference mesti 1 over total frequency minus 1. Okay, kalau kita ada 100, so sekarang 1 over 99 lah. So dapatkan dulu summation Fi, Si square, and then minus summation Fi, Si square kan, divide by your total frequency. Okay, that is your variance. You want standard deviation, so square root the value. So tunjukkan dia punya ni. So the same thing for your median. Median, what you need is your class boundary, lower class boundary. So dapatkan dulu apa class median dia. So total frequency divide by 2. N over 250. So tengok kat mana tu dia punya 50 tu. Okay. Kat mana tentukan dulu dia punya class median. Once dapat class median, tengoklah kumulatif frekuensi sebelum bagi dengan frekuensi kelas median, darabkan dengan dia punya lebar kelas tu. Okay, lebar kelas, upper class boundary minus lower class boundary. And then you check dia punya skewness ni. Calculate the skewness and give comments on the distribution. So, kita dah ada mean. Kita dah ada median. Takkan kita nak guna mean minus mode pula. Lagi satu kerja lah kamu nak kira mode. Mode, kau punya median mode tu tak ada markah pula. So, gunakan mean minus median tu. Okay. So, use that one for your formula. Check positive ke negative skewness. Okay, dah ada positive negative skewness apa? Left to the right, skew to the right. Apa dia punya comment dia. Okay. And then number 4, UTM has decided that 20% of the students were overweight. Okay, approximate the minimum BMI used by UTM to categorize overweight ni. Okay, kalau yang ni, apa ini persentan? Okay, 20% of the students were overweight. Approximately, what is the value lah? What is the minimum BMI used by UTM to categorize overweight? Okay, ini apa? Macam mana kamu nak selesaikan? This one. Sekejap, okey. Sekejap saya cek dia punya jawapan je. Lukman, kamu ada jawapan kat situ tu. Okay, the response kalau let's say if you already done, maybe you can check the answer for that one. Ya, saya tengok balik. Sekejap ya, saya punya di tengah loading ni. Sekejap. Okay, so kalau kita tengok dia punya, boleh dengar suara saya? Okay, kalau let's say. Okay, so the first answer, you get your mean here, 21.87. Okay, and then, betul. Okay, 5.1383. Okay. And then you punya median 22.1654. Okay, correct. You punya skewness. Okay, again, saya tak sure Luqman guna yang mana satu ni. Sama ada, kita better gunalah mean minus median tadi So 3 mean minus median divided by standard deviation. So you get the value and then this one is skewed to the left. So kalau kamu guna mean minus mode tu, dia punya value tu lain sikit lah. Tapi dia punya plus minus is the same thing. Okay. And then the last one, you get P, persental yang ke-80. So, okay. Boleh ya, yang lain tu? Dapat tak? Okay, so again so kita punya yang the last answer, number 4, okay, UTM has decided that 20% of the students were overweight. So approximately, what is the value? So what you need is to find your percentile yang ke-80. So percentile ke-80, as Luqman write the answer is 26.7808. Okay, so that one is correct Okay. Dengarkan suara saya ni. Saya punya ni kadang-kadang tak ni pula internet dia. Okay, the question number 3. So question number 3 ni kita dah buat hari tu dalam kelas, sama je. Saya ambil dari sini juga. Okay, so that one I will not discuss lah. So question number 4. Okay, so question number 4, you want to find your probability. Okay, probability A union B and probability A prime intersect with B prime. Okay, kalau ini boleh lebih mudah kalau let's say if you can draw your Venn diagram. Okay, draw dulu dia punya Venn diagram. Okay, sebab kamu nak tentukan dia punya probability dia. Okay, yang bahagian ni lah A prime intersect B prime. Kalau ini A union B, you just can write directly je lah. A union B, probability of A plus probability of B minus intersection. So A prime intersect B prime ni. So kalau A prime intersect with B prime, okay. So this one, it should have the same thing if you have A union B prime. Sorry, A union B and then prime. So 1 minus probability A union B. Okay. Kalau probability A union B, the answer is 0.7. Probability A prime intersect B prime, your answer should be 0.3. Okay, the answer should be 0.3. And then do you want to show this one independent? So kalau independent, since we know that A and B are independent, so multiply je lah. Kalau probability of A times probability of B is the same thing as your intersection, A intersect with B, so that means they are independent. Okay, justify your answer. Bagi reason, kenapa dia independent? Since you can write A intersect with B is probability of A times probability of B. So that one are independent. Okay, number 5. Just draw a tree diagram. Okay, draw a tree diagram. Okay, number 5, apa jawapan dia, Luqman? Can you write the answer? 5A tu tak apalah, draw je lah tree diagram. 5, 1, 2 and 3. Ataupun yang lain, ada tak? What is your answer? Oh, tak sampai lagi, okay. So, ini kamu dah bercek So, yang lain belum. Okay, I just write this on. Okay, number 1 So, you should get 0.891. Okay. Number 2. Nanti cuba buat. Okay, check dapat tak jawapan ni. And then number 3. 0.9167. Okay. So, this is the answer. So, kat sini kiranya kita ada tree diagram dia. Okay. So, draw a proper tree diagram relevant for the above situation. So, 1% of a population X has a disease D. Okay. Diagnostic test on the disease works on the following accuracy. So, if a person has disease D, then the test will show positive is 0.9. And if the person does not have the disease, then the test will show negative is probability 0.9. So, kamu punya first branch tu, maksudnya ada disease, tak ada disease. Betul, second branch, positive, negative, positive, negative. So, draw the tree diagram. Okay. And then use that tree diagram to find the probability. So, he does not have the disease and the test show negative. Maksudnya probability D prime, katakan does not have disease, and your intersection negative test, n lah, katakan n, okay, that is your negative. So based on your tree diagram, apa dia punya probability dia. Okay. Kalau yang kedua, he is detected positive. Kita dah tahu dia positif. You want to find probability positive. Positif sama ada dia ada disease ataupun dia tak ada disease. So expand the formula and use your tree diagram to find the value and then you solve lah. Tulis balik dalam bentuk jalan kerja dia macam mana. Okay, the last one, he does not have the disease given that he is detected positive. So this one is your conditional probability. Okay, conditional probability. Kita check lah. Kita nak dapat kenapa. Does not have the disease given that he is detected positive. Maksudnya probability that D prime given that P lah positive. So expand the formula using your Bayes theorem, and then solve. Okay, so basically 5 je tu lah dalam masa 75 minit. Okay, ada apa-apa soalan nak ditanya? Okay. So if anyone want to share the solution dalam Telegram pun boleh jugalah. I just go through and then other student can refer your solution. Okay. So nanti later on, sekejap ya. Ini sebab saya pakai. Okay. I stop record dulu. So komputer ni agak slow sikit. Saya pakai komputer satu lagi ni. So